Hi, my name is Jason Cardell. Today I'm going to explain my Perch project, which I've done for my instrumentation class here at Brigham Young University. And this project was designed in such a way that it can be integrated onto any Perch with the purchase of a few items, adding up to around $50. How this system works, and the major goal of this system, was to design a system which would enable a Perch ROV operator the ability to communicate with an underwater diver using known methods of communication. And so we achieve this by using Morse code to transmit a signal from the Perch ROV operator down to a diver, and the diver would respond via a camera, which is fed into a live video feed on a program which was designed specifically for this project. Now that I've gone over a brief overview of my project, I would like to spend a little bit of time explaining how exactly to build the components that need to be built, and some of the precautions that need to be taken, and also some of the other objects you need to buy. And I'll explain the reason behind these. And so the first object is a serial port to Ethernet connector. And so this cord, how you're going to use this is you're going to plug it straight into the serial port of your computer, and I've got just a simple extension here. And the other side of this cable, you are going to plug into a junction block box, which I will show you how to build. And here I've got them labeled so you can see where the serial port plugs in. Next, let's talk about the LED, which will transmit the Morse code from the Perch operator down to the diver, sending these Morse code impulses. What you're going to need for this is you're going to need a standard LED, 5mm, that's the one I used, and you're going to want a 1.5 kilo-ohm resistor. The reason I chose this resistance value, it makes the LED light up plenty bright, and it turns out that serial ports have a very low amperage threshold that they can transmit. And so, because this varies between manufacturers, I chose 1.5 kilo-ohm in order to be safe for this resistor. So what you're going to want to do is you're going to want to solder this resistor. It can be on either side of the LED. You're going to want to solder that on there, and once you have it soldered, you're going to want to heat shrink it. Make sure you heat shrink the entire length of the resistor. You can clip these ends off, which will make it a little easier. Next, you're going to want to attach the end of this resistor as well as this wire to the brown and brown-white wires coming from your Perch tether. These wires aren't used on the standard Perch, which make them especially good for our project, because all we need are 2 lines. Once you get these soldered and heat shrunk, what I have done, as you can see here, I have simply used an extra 2 pieces of heat shrink around the outside of the water. And so some of the other components that were necessary are a USB camera. I purchased this for around $25 from Amazon.com, and it is actually made this submersible. I again used some of this liquid tape, and I made sure to seal with multiple coats this backside where the camera goes into the cord, and also I sealed around the camera lens. Now, care needs to be taken so you don't get those LEDs covered up as well as the camera. Let's see this Morse code in action. Let's see if we can get this to work. And so what I've done is I've plugged that serial port cable into the serial cable port, and this is going to simulate the ROV and the ROV LED that you just built. So I'm going to go ahead and plug that in there and see if we can get it to light up. Alright, and so this should be transmitting SOS to the diver. So next I'd like to explain the purpose of the junction box and how to build it and the things to watch out for. And so here's my junction box with everything unplugged. I'm going to go ahead and take it apart. You'll notice on my faceplate, I went ahead and laser etched into the side there and label the different ports. That would be a great idea for you to do, even if it's magic marker, to go ahead and label those. And so this is what the inside of the junction box looks like. Pretty standard aluminum painted junction box. So the purpose of this junction box is to enable your Perch to be, in a sense, plug and play compatible. And so you already have brown-white wire heading to the Perch, which isn't being used. And so up here, I've wired the controller port straight to the ROV port. And I just went ahead and wired all the wires exactly on one as it is on the other. That way it's just a direct connection. Next, I wired the serial cable port to the Perch port. Since the brown-white terminals weren't being used by the controller, I went ahead and just tapped right into this port, and that enabled your serial port. And depending on the serial cable you get, serial to Ethernet cable you get, the connections could be, the pin locations which are located on the serial port could end up in a variety of different places on your Ethernet port. And so what you need to be careful of when you wire this up is that you take the RTS pin from the serial port or the DTR pin from your serial port. I've included controls in the program, which I'll show shortly, that enables you to use either of those ports. And you need to pin out using a multimeter or a test light which pins correspond. If you use a test light, you can hook this up to your computer, you can have your program running, and find ground, and then your RTS or DTR port. If you hook this up incorrectly, and there's a lot of documentation online for free that you can use as far as pinouts on both of these connectors, if you hook it up incorrectly, you could potentially damage your serial port. And so I'd be extremely careful on how you hook it up. So in a nutshell, that's my project. I've told you where you can go to learn more. I hope you've enjoyed watching. I've enjoyed the project, and I've enjoyed building the program and being a part of the Perch program. So please build it. It'll be great. It'll be fun. And good luck. I'm going to go ahead and take a moment to go through the bill of materials which I compiled for this project. This bill of materials lists all of the components which I used in my project, and I'll just go through the list one at a time. First, the endoscope. I purchased mine from Amazon.com, as you can see. One thing to keep in mind when it comes to this endoscope is to get one with a long enough cord. I found one that was especially inexpensive and had decent ratings online. Next is the RS-232 cable to RJ45 adapter. Now, this cable, the one I have listed here, has a fairly long extension on it. Next is the liquid tape. Liquid tape can be purchased at various hardware stores. It's very common. Next is heat shrink. Heat shrink, as well, can be purchased at nearly any hardware store. It would be good to get a variety pack so you can heat shrink both the small resistor wires as well as, other various cables that you might need to seal. Next is the junction box. I purchased one from Home Depot that was made out of aluminum. It was a little bit bigger than your standard blue electrical box, which goes on a wall and is a lot cleaner. It's made for outdoor use. There's nothing terribly special about this junction box, and really any would do. The next is the Ethernet plate. One thing to keep in mind when purchasing this Ethernet plate is that you need one with 3 Ethernet jack ports located in it. Next, you need 3 Ethernet jacks. Next is the LED. It was a standard 5mm LED which I used. You could purchase one of any color, whatever you prefer. The resistor, again, I recommend a 1.5 kilo ohm resistor. The tools needed for this project include a solder iron to solder your LED to the resistor, and your brown-white wires to the resistor and LED lead. Also, a screwdriver for your junction box. This is a screenshot of the program I developed, especially for this secret project. Again, the purpose of this program was to transmit a message via serial port in Morse code impulses to a diver underneath the surface and be able to see the diver to receive the hand signals via this USB camera and live video feed. You'll notice at the top there's the transmit window where you can decide what you want to send to them. There's a restart button where you can restart the transmission, and a stop button which will stop the loop which continually transmits the Morse code message. There's a delay time knob that you can use to adjust the speed of the transmission. Also, there's a toggle on the right hand side which you can use to toggle the RTS and DTR serial pins on and off. On the left hand side, you'll notice that there's copyright material information as well as the Perch website and my personal website where I have the files and instructions in installing this program. I hope you've enjoyed this presentation.